Ultrasound physics. I'm going to review the basics of ultrasound physics necessary to help you through musculoskeletal sound. So first off is a speed of sound in the body is equal to the wavelength times the frequency. So with Einstein this was c equals lambda squared, but in this case we're using the constant c, which is the speed of sound in the body. And that is not the same as in a vacuum or in space or in air or water. It's the average of that in the body itself, and that speed would be 1,540 meters per second. That's the number you need to remember and put to heart, because that is the average speed of sound in the body. And then when we decide to look at 1 millimeter reflectors in the body, we want to relate that to the wavelength of the sound wave, and the fact that we can then multiply the wavelength and the frequency to get the constant. I made this pretty simplistic, but the bottom line is 1,540 meters per second. If you have 1 millimeter reflectors, then the frequency would be at 1.54 megahertz. Now in the early 70s, that's when diagnostic ultrasound really came to fruition. This is the area that we were looking at in frequency, and therefore that was the problem, because we had 1 millimeter dots that we could not really see whether it was a boy or girl or not unless you had a lot of experience. And so this is really inadequate for any resolution or diagnostic resolution at this point. So we want to do something at a higher frequency or a shorter wavelength, because the average speed of sound in the body is not going to change. And the fact is the only thing we can really change is the frequency of the probe. So that's the part we can change. So if we take this formula and we want to increase the resolution, which means we want to make these reflectors or these wavelengths shorter, we then can we can say, let's say we want them to be 1/10 of a millimeter apart. So the speed of sound in the body is a constant, and reducing the wavelength by tenfold means that the frequency is increased by tenfold. So that is at 15.4 megahertz. So this is the only variable that we can change, and to change our overall resolution. So now the problem is there are things that related to penetration that become a problem when you start to increase your frequency or reduce your wavelength, and we're going to go over that in a minute.